Landing a fighter jet on an aircraft carrier is one of the most difficult and dangerous maneuvers a pilot can face. But are they doing it in the middle of a storm? That's on another level entirely. For Navy pilots, the deck of an aircraft carrier is like a moving target, especially when fierce winds and turbulent seas come into play. Yet, time and again, the United States F-35 fighter jets have defied the odds, landing safely in the harshest conditions imaginable. In today's video, we're diving deep into the incredible technology, precision, and training that allows the F-35 to land on an aircraft carrier during a wild storm. We'll explore the groundbreaking systems that guide these jets, the incredible skill of Navy pilots, and what makes the F-35 a force to be reckoned with in both the skies and on the seas. Before we start, subscribe and hit the notification bell to stay updated with more thrilling content on military technology and aviation. Now, let's take a look at just how challenging this feat is. Landing an aircraft on a carrier is already a high-stakes mission, but landing during a storm, that's a true test of technology and training. Let's explore why. An aircraft carrier may seem massive when you see it from the shore, but the truth is that its landing deck is incredibly small for modern fighter jets. A typical runway on land can stretch for kilometers, but on a carrier, pilots have to land their jets on a strip that's only about 150 meters long, that's less than 500 feet. The F-35, like other combat jets, approaches the carrier at high speeds, often over 150 miles per hour, that doesn't leave much room for error. On top of that, the carrier itself is constantly moving, pitching, and rolling with the waves. When strong winds and stormy conditions are added to the equation, it's a recipe for disaster unless you have the right technology and training. Storms bring more than just rain and wind, they bring unpredictability. The ship moves up and down in rough seas, often changing the angle of the landing deck in real time. This makes it incredibly difficult for pilots to line up their approach, slow their aircraft, and make a safe landing. Visibility drops, the wind pushes the plane off course, and the margin for error shrinks even further. Yet, despite these challenges, F-35 pilots manage to stick their landings time after time. So, how do they do it? The answer lies in a combination of advanced technology and the sheer skill of the pilots who fly these remarkable jets. The F-35 isn't just any fighter jet, it's the most advanced combat aircraft in the world. With speeds of up to Mach 1.6 stealth technology and state-of-the-art avionics, the F-35 represents the pinnacle of modern military aviation. But what truly sets the F-35 apart in these challenging landings is its computing power. The F-35 is often called the quarterback in the sky because of its ability to process and manage an overwhelming amount of data, giving the pilot a near-perfect awareness of the battlefield. But this same technology also helps pilots land safely in extreme conditions. The jet's avionics systems provide pilots with real-time updates on everything from their speed and altitude to the exact position of the aircraft carrier below them. Imagine trying to land a plane in the middle of a storm, with your only reference points being what you can see through the rain and fog. The F-35 changes the game with its heads-up display, which projects critical information directly onto the pilot's visor. This allows the pilot to keep their eyes on the target, whether it's a runway or the deck of an aircraft carrier, while staying fully informed of the aircraft's performance. One of the most important systems on the F-35 for landing in difficult conditions is its Delta Flight Path software. This program helps the pilot manage the aircraft's glide slope, providing tiny adjustments in real time to ensure a smooth and stable approach. When combined with the jet's advanced navigation systems, the F-35 becomes far more than just a fighter, it's a flying computer, constantly making calculations to keep the pilot on course, even in the middle of a storm. But even the most advanced avionics systems wouldn't be enough to land in a storm without the help of the Joint Precision Approach and Landing System, or JPALS. This groundbreaking technology allows F-35s to land on aircraft carriers with pinpoint accuracy, even in the worst weather. So, what exactly is JPALS? In simple terms, it's a GPS-based system that allows the carrier to talk to the aircraft as it approaches for landing. Sensors on the ship and in the jet work together to create a real-time picture of the jet's position, speed, and trajectory. This data is then fed back to the pilot, helping them make micro-adjustments to their approach. JPALS doesn't just work in clear weather, it's designed for all-weather use, meaning it can guide pilots to a safe landing even in dense fog, heavy rain, or the roughest seas. The system uses encrypted GPS signals to ensure accuracy and security, so even in the chaos of battle or a storm, the F-35 pilot knows exactly where the carrier is and how to land. Another critical component of the landing process is the Fresnel lens, a system of lights on the deck that helps pilots align their approach. When the lens is centered, the pilot knows they're in the right position. If it shifts, they have to make quick corrections. It's an old but effective tool, and when combined with JPALS, it gives pilots the confidence they need to land in even the most extreme conditions. Of course, technology is only part of the equation. Landing a fighter jet on a carrier, especially in a storm, requires intense training and precision. Navy pilots spend years honing their skills, practicing landings in all kinds of conditions day and night, calm seas and rough waters. Before they ever step foot on a carrier, pilots undergo countless hours in simulators where they can practice landing in simulated storm conditions. These simulators recreate everything from heavy rain and strong crosswinds to the sudden changes in deck position caused by rough seas. Landing on a carrier is like trying to thread a needle in the middle of a hurricane. The deck is moving, the wind is howling, and you have to hit your mark perfectly. But with the right training and the advanced systems we have in the F-35, it's something we can do with confidence. When it comes to landing in a storm, precision is key. Even a small mistake can lead to disaster, which is why pilots are trained to react quickly and stay focused under pressure. The combination of their skills and the advanced technology in the F-35 makes these landings possible, even in the worst conditions, absolutely. Let's continue expanding the video script, diving deeper into the F-35's design, its landing systems, aircraft carriers, and more to maintain the flow and reach the full script length. The F-35's engine is a marvel of modern engineering, designed to keep the aircraft stable and responsive, even in chaotic conditions. It's not just about raw power, though. The F-35's sleek, aerodynamic shape allows it to cut through the air with minimal drag, helping maintain a smooth approach during landing. This design is particularly important during stormy conditions, where strong winds can buffet the aircraft and make it harder to control. Stealth is one of the F-35's most well-known features. While it's designed primarily to evade enemy radar, the aircraft's stealth features also contribute to its stability in flight. The smooth, angular surfaces of the jet help reduce turbulence, making it easier for pilots to control the aircraft, even when facing crosswinds or erratic weather conditions. But what about the landing gear? The F-35's landing gear is specially designed to handle the harsh conditions of a carrier landing. Built to withstand the incredible force of an arrestor hook landing, the gear can absorb the impact of hitting the deck at high speeds. This is especially crucial in a storm, where pilots may need to make faster, harder landings to avoid overshooting the deck. Let's shift focus for a moment to the aircraft carrier itself, the platform that makes these landings possible. When a storm rolls in, it's not just the pilots who face a challenge. The crew aboard the carrier must work together to ensure the deck is ready for landings, even in the worst conditions. The deck crew, the ship's navigation team, and the engineers all play a critical role in this high-stakes operation. When a carrier is hit by stormy weather, the ship doesn't just ride out the waves. The crew adjusts the ship's speed and direction to minimize the impact of the storm on the flight deck. This requires constant communication between the ship's captain, the flight control officers, and the pilots in the air. Everyone has to be on the same page to ensure a safe landing. In a storm, everything becomes more difficult. The ship is moving a lot more, so we have to make sure the deck is secure and ready. The arrestor wires are checked and double-checked, and we keep in constant communication with the pilots to let them know how the ship is moving. Every little piece of information helps them adjust their approach. Aircraft carriers are designed to handle rough seas, but that doesn't mean it's easy. When the waves get high and the winds pick up, the carrier's deck can pitch and roll unpredictably. This adds a whole new layer of complexity to the pilot's job. The deck can move several feet up or down in a matter of seconds, which means the pilot has to be ready to adjust their landing approach at the last moment. This is where the Joint Precision Approach and Landing System comes into play once again. JPALS allows the ship and the aircraft to communicate, providing real-time updates on the ship's position and movement. This helps the pilot compensate for any sudden changes in the deck's height or angle, ensuring they touch down safely even in the middle of a storm. But landing isn't the only concern during storm operations. Once the aircraft touches down, it has to be quickly secured to prevent it from sliding or being damaged by the rough seas. Deck crews use chains and other equipment to tie down the jet, ensuring it stays put as the carrier rides out the storm. One of the most critical components of a carrier landing, especially in stormy weather, is the arresting gear system. This system is responsible for stopping the aircraft once it touches down using a series of heavy-duty wires stretched across the deck. When the F-35 comes in for a landing, it deploys a tail hook mounted at the back of the jet that catches one of these wires. The arrestor wire is connected to hydraulic systems below the deck, which absorb the kinetic energy of the aircraft and bring it to a stop in just a few seconds. This entire process happens in the blink of an eye, and it's essential for landing on a carrier where there's no room for error. In stormy conditions, the arresting gear system becomes even more important. The pilot might not be able to reduce their speed as much as they would in calm weather, which means the arrestor wire has to work harder to stop the jet. The system is built to handle this extra strain, but it's a testament to the engineering that these systems can stop an F-35 traveling at over 150 miles per hour, even in rough seas. Behind every successful F-35 landing on an aircraft carrier is a dedicated crew working tirelessly on the flight deck. These are the men and women who make sure the carrier is ready for landings, who secure the aircraft after touchdown, and who keep the deck safe for both the pilots and the crew. In stormy conditions, their job becomes even more dangerous. The deck is slippery, the wind can blow them off balance, and there's always the risk of being struck by a moving aircraft. Despite these challenges, the deck crews perform their duties with precision and care, ensuring that every landing goes as smoothly as possible. Working the flight deck is tough on a good day, but when you add in wind, rain, and rough seas, it's a whole different game. We have to be extra careful to stay safe while also making sure the aircraft is ready for landing. It's a team effort, and we rely on each other to get the job done. One of the most dangerous tasks deck crews face during a storm is securing the aircraft after it lands. Once the F-35 touches down, it has to be chained down quickly to prevent it from moving. This is especially important in rough seas, where the motion of the carrier can cause the jet to slide or shift unexpectedly. Deck crews use special tie-down chains to secure the aircraft to the deck, ensuring it stays in place no matter how rough the seas get. This is a delicate balance, securing the jet without damaging it, while also making sure it's safe from the elements. The deck crews are the unsung heroes of the carrier's operations. Without them, it wouldn't matter how advanced the F-35 or its landing systems are, the aircraft simply couldn't land safely. Landing a fighter jet on an aircraft carrier is one of the most challenging feats in aviation. Doing it in the middle of a storm is nothing short of incredible. But thanks to the advanced technology of the F-35, the skill and precision of Navy pilots, and the dedication of the deck crews, these landings happen every day in some of the most extreme conditions imaginable. The combination of JPALS, Delta Flight Path, and the F-35's incredible avionics systems gives pilots the tools they need to land safely, even when the deck is pitching and rolling beneath them. And with the support of the carrier's crew, these jets can continue their missions no matter what Mother Nature throws at them. So, the next time you see an F-35 landing on a carrier in a storm, remember the incredible teamwork and technology that made it possible. It's a testament to the skill of the pilots, the engineers, and the crew that these landings seem almost routine, but they're anything but. Thanks for watching. If you enjoyed this video, be sure to hit the like button and subscribe for more content on the world's most advanced military technology. Stay tuned for our next video, where we'll dive even deeper into the advanced innovations shaping the future of aviation.